Hello everyone, you're welcome to my YouTube channel, and this is IX. So today we'll be evaluating these limits and we'll be evaluating them using L'Hopital rule. Of course, L'Hopital rule employs the use of differentiation, derivatives, and it's so important because there are places where simplification cannot work, substitution also cannot work, and we have just to resort to L'Hopital rule. So let's see how it goes. So for number one, the limit as x approaches 0 for x cube plus pi x all over sine 3x. So what we'll do is that we'll differentiate the numerator and the denominator differently, not by quotient rule, differently. So to differentiate the numerator, we'll get, of course, before using the L'Hopital rule, we have to substitute and see. See that x approaches 0, so sine 3x is sine of 0, and sine of 0 is 0. You don't want to do that, right? You don't want to divide by 0. That's a red flag for you. So that's why we are resorting to L'Hopital rule. So to differentiate x cubed plus pi x, we'll get, this comes here, so we'll get 3x squared plus pi. Divide, if we differentiate sine 3x by chains rule, we'll get 3 cos 3x. So our limit as x approaches 0. So this is what we'll get, and at this time we can now substitute x for 0. Substituting x for 0, here 3 0 squared is 0. So we have 0 plus pi, which is equal to pi all over cos 3x, which is cos of 0, because x is 0, so cos of 0 will give us 1. 1 times 3 is 3. So yes, this is it. So the limit of x approaching 0 for the function x cubed plus pi x all over sine 3x is equal to pi over 3. Yeah, and that's by L'Hopital rule. So we could actually try number 2. Limit as x approaches 0 for the exponential function okay. So you can also see with me that you cannot substitute, right? Yes, you cannot substitute because x approaches 0. You cannot have 0 at the denominator. So we have to what? Differentiate both the numerator and the denominator separately. Again, not by quotient rule. So to differentiate the numerator, every time we differentiate e raised to the power of x, and anytime we also integrate e raised to the power of x, we'll get same thing as if nothing ever happened. So e raised to the power of x, if we differentiate it, will give us e raised to the power of x. To differentiate e raised to the power of negative x by chains rule, we are going to get negative e raised to the power of negative x. E raised to the power of negative x by differentiation, we'll get negative e raised to the power of negative x. That's what we'll get. Now this negative meeting with this negative gives you a positive. So finally we have plus e raised to the power of negative x. When we differentiate x, we get 1, right? So, and you don't want, it needless of dividing by 1. So this is what we'll get. And our limit for x approaching 0. At this point, this will give us e raised to the power of x plus 1 over e raised to the power of x by indices, right? By indices. So we can actually substitute 0 now. E raised to the power of 0 will give us 1 plus 1 all over 1, which is 1, and that's equal to 2. And that's equal to 2. Yes. So the limit as x approaches 0 for e raised to the power of x minus e raised to the power of negative x all over x is equal to 2. Is equal to 2. Now, follow me as we attempt, like I said, the last question is very, very interesting because looking at it is still by L'Hopital, because if you substitute x for 0, you don't want to divide by 0, right? Yeah. So by L'Hopital rule, we are going to differentiate the numerator separately and differentiate the denominator also separately. But look at the function we have. This is the function a raised to the power of x. That's the exponential function you have there. This is different from saying x raised to the power of 5. It's not same thing as 5 raised to the power of x. They are not same thing. So how do you differentiate this then? How do you differentiate this then? Okay, to differentiate this, every time you want to differentiate a raised to the power of x, every time you want to differentiate a raised to the power of x, you'll be getting this as your result. A raised to the power of x ln of a, right? So for 5 raised to the power of x, you'll be getting 5 raised to the power of x ln 5. Yeah, that's what you'll be getting. So for this now, we'll definitely have limit as x approaches 0. If we differentiate 5 raised to the power of x, we will get 5 raised to the power of x ln 5. If we differentiate 1, we'll get 0. So we'll do that. Divide through. If we differentiate x, we'll get 1, of course. So needless of dividing, right? Needless of dividing by 1. So this is 5 raised to the power of x ln 5. At this point now, you can resort to substitution. That means substituting x for 0, right? So you have 5 raised to the power of 0 ln of 5. And 5 raised to the power of 0 is what? 1. So this is 1 times ln of 5, and that's ln 5. And so the limit for 5 raised to the power of x minus 1 divided by x as x approaches 0 is ln 5. And that's the answer. If you love this video, I need you to subscribe. You can like and share it with your friends if this video is helpful to you. So up until we meet again.